So today we are going to start a new approach, which one is a divide and conquer approach. Right. So what is divide and conquer approach? So this approach is in three parts. This approach is divided in three parts. The first one is divide, in which we are going to in which we are dividing all the data, right, in small parts. Right, so we are going to break down all the elements in different parts. Right, let's suppose we have one problem P. Right, that P problem is going to divide into number of problems like P1, P2, P3 and so on. Right, so breaking our problems into sub problems, breaking in a single large problem into smaller small sub problems. Right, and after that we are going to solve. Then the approach second one is conquering. So solving, now these small problems are now going to solve, and we are going to receive some solutions that are called, if we have P is a big problem, large problem, and P1, P2 up to Pk, we have small sub problems. Now for every small sub problem we have some solution. Right, so we are going to find. Now conquering means solve sub problems and we are going to receive some solution and find solutions of each problem. Right, and the third and the final step is combining, or we can say combine approach. So we are going to collect all the sub solutions, all the sub problem solutions, and and create a final solution. Right, or we can say join all the sub problem solutions. Right, so this is the basic concept of divide and conquering approach. Now graphically, if I am going to represent, let me show you. we have a large problem which is P. Now P is going to divide into some different problems, P1, P2, P3 up to Pk, or we can say Pn problems, we can say having right like this. Now each P1 having, this is P1 is basically sub problem. Now we are having some solution that is for S1, again S2, S3 and so on up to SK. SK solutions we have, right? Now all the solutions we are going to combine in a and making a complete solution. So this is the graphical representation of this divide and conquering approach. In same way we can write like algorithm for this. How we can write algorithm? If we want to write algorithm, we already discussed. Now how we can write the algorithm for this? Let's suppose divide and conquering approach, having one problem P, it is going to divide we are going to divide. If we have a small problem P, then we are going to return the solution of this problem, right? If not, else this technique we are going to follow. Else if I am going to write here, else we are first divide P into P1 comma P2 comma P3 comma up to pk, right? Pk problems, and after that we are going to apply divide and conquering, and we are going to divide applying approach for P1, applying for this to find some solution, right? Then again same method for P2 and so on for Pk, right? After that we are going to combine all P1 comma P2 and so on Pk. So this is the approach. Then so this is the method which we have. Right, so this is the approach. Now the next thing we are going to, we have various or problems which we are going to use like in this divide and conquering approach. So I am going to write some few names. The first approach we have discussed binary search. All right. Then we have one more problem, find maximum and minimum. Then the third one we can say quick sort, or the fourth one we can write merge sort. There are some more like matrix multiplication. All right. So these are the general problems which are present coming in this divide and conquering approach, right? So now first I'm going to explain some algorithms. When we are going to discuss any algorithm, your responsibility becomes that you must know the that its worst case complexity, average, best case complexity, how we can find, how we can calculate with some examples, right? We have already learned some methods to calculate complexity, right? So how we are able to find the complexity of any method algorithm, right? So first we are going to learn the concept of quicksort, right? So is it clear to everyone till now? If anyone has any doubt, any query, you can discuss. You can discuss with me if you have any doubt, or raise your hands. If there is no doubt, then raise your hands. Okay. Rest of the students, okay, lower your hands, dear students. No. So next we are going to learn the algorithm, the working concept of quicksort algorithm. Then we are moving to the further mode. So here we have quicksort, right? Let's suppose we have some elements here. I'm going to write some elements. Let's suppose one example I'm going to take. Let's suppose 35, 50, and any random values we can use. 15, 25, let's suppose one more, 80, 20, 90, and 45, right? So this is, let's suppose this is my list, right? So in this we have a list of some values, right? So how we can apply, how we are able to apply quick sort. So in quick sort, first we are going to select a one pivot element. The first element we can take as a pivot element. Pivot element, right? This is 35. You can see the list and you can randomly you can select the first element we have selected right now. Now what next we are going to do? Next we have, this is the pivot element, this is my P, and this is my Q end, P end and Q end, right? So if the P element is greater, right, then greater than this pivot element, if P element is greater than this pivot element, then we are not shifting, we are not moving to the next. But if the element is small, then we are going to move to the next. Let's suppose this becomes 25, 50 becomes 25, so 25 is less than, so we are moving to the next, right, from the pivot element. But right now it's 50, so P is not changing, and Q is also, if element is less than, element is greater than or less than, if the pivot element is greater, P pivot element is greater than this value, in the both the cases the pivot element is not greater, right? Clear? So what we are going to do in this case, if we are moving to the, if Q is greater than pivot element, then we are moving, we are dividing two lists, right? One on a left side of the 35, one on the right side. Right side elements are greater than and left side elements are smaller, right? So if if this value Q value is greater than 35 pivot element, then we are moving to the next. So Q are coming to this, pointing to this one, right? So next we have 20. Write down this property. So 20 is less than, when we receive Q element less than pivot element, then we have to stop, or when we receive P element greater than pivot element, then we have stop. So stopping conditions are two. Stopping conditions, I'm writing here, stopping condition, stop condition. So first condition we can say P. Very important points, all can write down. If P is greater than pivot element, then we are we are fixing this value, means we are not moving. then we stop at that position. Stop at that position, right? In same way, if Q is less than pivot element, then we stop at that position. Clear? The first points are clear to everyone. Here I am going to copy these. Yeah. Now next, so Q is going to move at this point. Now if both the conditions we found P and Q, both the elements we stop. So now we are going to interchange. We are now swapping both the values. So now the new value becomes 35, 20, swapping of P and Q, 15, 25, 80, 50, 90, 45. Right? Now P is at which position? At this position. Here is P and Q at 50. So next element is, if we are going to again, we are going to receive. So now 50 is again more than this pivot element. We are moving to the 80. Then again we are going to move to the which part? 25. Right? So this is my new Q value. Right? This is new Q. And again P is again here, and again at 25, again an 80. Now P comes at this point 80. Very important point. When P reach at this point, and here we have the third point, when both the P and Q are going to cross, then what we are going to do? What we are going to do? We are going to swap the element. We are going to swap the element. Which element? Now we are going to do swapping of pivot element with Q element. And now the third point is swap pivot and Q element. So if we are going to swap now, what new value we have? Sorry, 25. Here we have 25, 20, 15, 35, 80, 50, 90 and 45. One more point I want to discuss here. Here is plus infinity. Let's suppose p is less than this, and we are moving to the up to infinite, because infinite value is the largest value. Negative, negative, negative. At the end, we receive plus infinity. Plus infinity means highest value. At that point, we are going to stop. In same way, but when we reach at q, q is going to reach at 35. So in that case, if it is going to reach at this position, indirectly you can see here p and q are going to cross. If p and going to cross, we are going to shift the values, right? So now, till now here, this is called the first pass. We can say pass 1. A very important point next. So our pivot element is this, that time. Now you can see here all the at first pass we are able to sort in two parts. On the left side you can see all the smallest elements from the pivot element, and on the right side all the largest elements on the pivot element, right? So q is there at this point, that time p is at this point. So now again we are going to start for new series. Again we are going to start with new value. So now this time we are going to make the pivot element. For this, it is the pivot element, because 35 is now at fixed position. Pivot element. Now this is my p, and there is q element. This is going to point by p and q, and here we can write plus infinity if it is not crossing. Here this element becomes p, and this becomes q element. Anyone has doubt in this first pass? Now this p is now less than pivot element, so it is going to move. It is moving. Yes, yes, I'm going to repeat. I'm going to repeat here. Now at first pass we are able to sort our list in two sub parts, right? So sub parts are like, one is on left side, right, another is on right side. So left side elements are smallest than previous pivot element, which is 35, and on right side all are the great more values from the previous pivot element, which is 35, right? So now again we are going to apply p and q to left side or right side, both sides. So now very important point this time. Now p is going to move this point because p value is greater. Then we are going to stop, means we are not stopping right now. So p is going to move to the 15, and then plus infinity. So and q is, what is q? Q is less than. So both are at which point? Same point, or next element is 35. So we stop p at this point 35. Just suppose p stop at this point. So we are able to cross. If we are able to cross, what we need to do? We need to swap. We need to swap with pivot and Q element. So 15 at this point, there is no change in 20, and then 25, then 35. Now we are implementing on the right side. So this is less than, so moving to the 90. So P is going to stop at this point, right? So Q is already stopped. Q is already stopped at this point because Q is less than pivot element. If Q is less than pivot element, then we are going to stop. If P is greater than, then we are going to stop, right? So Q is less than pivot element, so we stopped at this, and P is at this point now. So we are going to swap P and Q. So the new list becomes 80, 50, sorry, 80, 50, 45, 90, right? Then plus infinity. Now P is at what point? P is at 9, at 90, or we can say at this point. Now it moves to the this, and Q is at 45. Again it is going to move to the previous element. Once again I am going to repeat. The previously P is at this point and Q is at this point. After new values, Q is there at 90 and P is moving to the 90. So new P becomes at 90. So both are on the same place. Now P is greater than, so Q is moving to this 45. Both the conditions now crossed, P and Q now crossed each other. If both are going to cross, we are going to replace P and Q, means swapping. 50, 80, 90. Then 15, 20, 25 and 35 already we have sorted, and 35. So this is the final result we have received. Final result. So now if you have any doubts, you can ask.